jump around a little bit. So I will tell you what pages you need to be on and so on. Today we're going to look at Module 5 Lessons 2 and 3 and 4. All three lessons, 2, 3, and 4, focus on the area of a triangle. We're just going to look at different types of triangles, okay? So starting with Lesson 2, first just everybody look at the board and let's chat about it for a minute, okay? Going back to what we discussed last week, area of a rectangle is base times height. Well, if we look at this triangle, what do we know about this triangle in relationship to the rectangle? It's half of it. This triangle is half of the rectangle. See, if I copy it and put it in, it's exactly half. It matches. So how would I be able to find the area of the triangle? If the triangle is half of the rectangle, and the rectangle is base times height, how am I going to find the triangle? Right, I'm going to look at half. 1/2 base times height. Multiplying by a half is the same thing as dividing by 2. Multiplying by a half and dividing by 2 are the same thing. We know that. Okay? So now that we see how to find the area of a triangle, look at page 7, number 6. Page 7, number 6. Let's make sure we follow all the steps and you take good notes. You want to use these notes for your homework so that your homework is good practice when you have the test. The first thing I'm going to be looking for is the formula. You always want to write the formula first. The second step is to replace your letters with your numbers. So look at that picture. What is the base? 8 2/3 is the base. Now be careful. What is the height in that picture? Think about what we discussed when we did our parallelograms. What is my height going to be? Right, 5 3/5. So this is my height, and that was my base. Why can't I use 10 1/3? What's kind of like a requirement for the height? What does it have to do or meet or have? Right, the height has to be perpendicular to the base, which means it has to form a right angle with the base. It's usually written in that order, but remember that multiplication is commutative, so now when we multiply them, we can multiply them in any order, and we're actually going to practice that later on. So for now, what is my rule for multiplying mixed numbers? What do I have to do when I multiply mixed numbers? Right, make them improper fractions, and I do that by multiplying and adding. So 3 times 8 is 24, plus 2 is 26, and my denominator stays the same. 5 times 5 is 25, plus 3 is 28, and my denominator stays the same. Now I know my rule for multiplying fraction is to multiply all my numerators and then multiply all my denominators. But can I cross-reduce something to make some of the numbers a little smaller? Is there anything that I can cross-reduce on an angle? The 2 and the 26. 2 divided by 2 is 1. 26 divided by 2 is 13. It's like reducing a fraction, except we're going on an angle at the two fractions, the numerator of one and the denominator of the other. There's nothing else that we can cross-reduce. So the first thing we're going to do is multiply our numerators, and then we are going to multiply our denominators. Now I said on the do now that you could take out your calculators. My denominators, I know 1 times 3 is 3, times 5 is 15. But for my numerator, what is 13 times 28? What's 13 times 28? 364. Can I leave that as an improper fraction? So divide. What is 364 divided by 15? What is 364 divided by 15?
24.2.
All right, 24. I'm going to stop you there. 24. But I need to know how many would be left over. So what I could do is, what's 15 times 24? Yes. 360. So 24 times 15 is 360. So how many would be left over? 4. And then I always have to label it meters squared. Okay? Pretty straightforward. They were just some bigger numbers, and I like that we got a little fraction review in there. Okay? Don't be intimidated by big numbers. Just go one step at a time. You don't turn your papers yet. I'll tell you where to go. Now we're going to take a peek at some of the examples from lesson 3. How did we find the area of the rectangle? I said not to switch pages yet. Base times height. How did we find the area of the parallelogram? Well, it was still base times height, but we had to find the height by making a right angle with the base. We just talked about that a little bit. Remember how we were finding on your homework? You had to find the different heights. Well, sometimes we have to do that with triangles. The example we just did was nice and easy to find the height because it was a right triangle. If you look at this picture here, we have a right angle. So here is our base, here is our height, because our height forms a right angle with our base. So far, so good? But now look at this middle triangle, this isosceles triangle. Do we have a right angle? No. So we have to find the height. I can go from this angle and go straight down, and now that forms a right angle with the base. So I don't know, maybe that would be about 5. So that's our height. But look at this obtuse triangle. Could I do my height here? No, because is that my height here? No, I would have to make it bigger. Is that my height here? No, that's smaller. So that can't be my height. Where am I going to find my height? Yes, just like we did on our homework with the parallelogram. So this is going to be our height on the outside. So maybe that would be, I don't know, 8. Okay? So it depends on the type of triangle. The two of you have been talking a lot, and it's been very disruptive. So you have to look at the type of triangle to determine what the height is. The right triangle is the easiest because it's there. We like the right triangles. Okay? Now, let's take a look at page 11. Number 1, put your calculators down. We're not going to need them. Page 11, number 1. This is in lesson 3. Excuse me. In this acute triangle, we found the height on the inside of our triangle. Okay, I think I stopped choking. We'll continue the recording. So here we have a regular triangle. All right, so when we look at, I knew I was going to grab the wrong one. Seriously? Okay, so we had the triangle. We had to draw our height there. Well, what do you notice? What happened when we drew the height, also called the altitude? When we found the altitude, what did we end up doing to our big triangle? Two little triangles, and those little triangles are right triangles. And we just agreed that finding the area of right triangles was easy. So why don't we find the area of this blue triangle, then find the area of the pink triangle, and we can add them together to find the total area. So the first step is always to write the formula. So write the formula. Let's do the blue one first since it's on the left. So area equals 1/2. What is the base of my blue triangle? Times 9. And what is the height? Be careful. Remember that the height has to touch the base at a right angle.
12 centimeters.
Beautiful. Excellent. Now, before we had talked about putting the half at the end, multiplication is commutative. I'm going to take advantage of my half to make one of those big numbers, not just so big. Because I don't know about you, but I can't do 9 times 12 in my head. So why don't I do half of 12 first? What's half of 12? 6. Bring down your times 9. What's 6 times 9? 54 centimeters squared. But that's just the area of the blue triangle. Now let's find the area of the pink triangle. Area equals 1/2. What's the base? What's the base? 12.6. What's the height? Still 12. Again, let's do half of 12 to make it easier. Could use your calculators. What's 6 times 12.6? The calculator is going to be a distraction. Before I tell you when to use it, I'm going to take it away. 75.6 centimeters squared. But that's just the pink. So what do I have to do to find the area of the whole thing? Exactly. Let's add them up. So 54 plus 75.6. You can keep working down. I'm sure you're running out of room. We're not doing the next one. So if you want to keep working down. 0.6912 centimeters squared. That's one method we could use to find that area. The other method is to let's just find the area of the whole rectangle. I don't know, try that way. So area a triangle. I'm oxygen deprived from when I was choking. Okay, so area equals 1/2. What is the base of the entire triangle, if you want to be all technical and call it the right shape?
It would be 10 and 6 times.
Yup. What's the height?
12.
Yep. Again, let's make smaller numbers. 1/2 of 12 is 6 times 21.6. Use your calculators. Did we get the same answer? Yep. So you can use either method. You could just find the area of the entire triangle or the area of the two rectangles, as long as you remember to add them together. Okay? Yeah.
Like, I don't get with the second one where it was like A equals like 1/2 times. Is that 12 or 21?
Here, 21.6, because here's our base. The base was 9 plus 12.6. to get this whole thing as a base. That whole thing was our base. Do you see it? Nicole?
Yes.
This whole thing, whoops, the whole thing was our base. So we had to add them together. So you see where the 21 came from?
Yeah.
Okay. Other questions on this? You don't need a dry erase marker. That shouldn't be out. Please put it away. Okay, now we're going to take a peek at example from lesson 4. So please turn to page 15, the opening exercise. And let's practice finding the height. So right now in your notes, identify the height or altitude in each triangle. Probably take the cap off before I try to drink it. Bless you. So for number 1, here is our height. For number 2, here is the height. For number 3, we actually are going to have to draw our height on the outside. So it forms a right angle. So there's our height. You want to label them all with the right angle.
Did you do on the first one outside the shape?
Number 1, yeah, you could have gone like this. That's the height. You could have gone like that. That's the height. And if you notice, that is the same as that, which is the same as that. So you could have done any height. So on page 17, turn to page 17. I told you I'd talk you through it and help you find where we are. Page 17, number 6. Here's a triangle. They labeled everything for you. First step, write your formula. Area equals 1/2 times base times height. Be careful. What is your base of just the triangle? I only want the base of the triangle. No. Look, the triangle is just the white shape. Okay, I'm actually glad you said that so we could point it out. That's your base. This is just extra hanging out. That's not important. We don't need that. The base of just the triangle is 24. You see that? Looking at just the white triangle. It can be confusing on your paper because everything is white. So I would suggest maybe taking a yellow or an orange or a pink colored pencil and shading in the shape so you can see just what the triangle is. Not right now, but on your homework if you have to. What's the height? 42 is the measure of this side. We said that the height has to form a right angle. How tall is it? That's not going to go up 42 inches. That's not 42 inches tall. How tall is that? 8. Now, it's not always going to be tall, so I'm reluctant to use that word, but I think it helped you see where I go, what it means to be the height. Well, I'm going to do half of 24 first to make that smaller. Yep. Times 8. 12 times 8 is 96 inches squared. Area is always squared. Okay? Yes. They just wanted you to have more practice. And because I want to get more cover, we're going to condense them. There's some good stuff in here. And because you also have prior knowledge of area triangles, where now with the new Common Core curriculum coming through, I don't know if there's as much triangle experience. So future years, they may need more practice. You don't need as much practice because you've already been exposed to this. So we had to spend a lot of time on tape diagrams in the beginning of the year because you never knew tape diagrams. In the next couple of years, I'm not going to have to teach what a tape diagram is because they're going to have already learned it. But I need to spend more time on triangles because they won't have had it. So right now we can trade it off and do 3 and 1. They also make it a little more advanced in some of the examples. I picked some of the simpler ones. All right, let's just write this one out, number 7. Area equals 1/2 base times height. Area equals 1/2. What's the base of this? What's the length of the base? Excellent. What's the height? Ash, what's the height? Excellent. What's the rule for multiplying mixed numbers? What do I have to do to mix numbers? No. What do I have to do? Improper fractions. 4 times 12 is 48 plus 3, 50, 51. 9 and 1/2. 2 times 9 is 18, plus 1 is 19 over 2. 2 times 4 is 8, times 2 is 16. You can use your calculators to multiply and change back to a mixed number. What'd you get?
I don't have the answer, but I just have a question. Like, where did you get 16 from?
2 times 4 is 8, times 2 is 16. I multiplied all my denominators together. Then when I multiplied 1 times 51 times 19, it's 969. 16 goes into 969 60 times with 9 left over. And we have to label it feet squared. So in closing, how are the area formulas of rectangles and right triangles related? Well, every type of right triangle fits exactly half of a rectangle that has the same base and height. We saw that on the first slide with the blue triangle that I flipped around. When a triangle is not a right triangle, we can find its base and height by drawing the height or the altitude from the vertex or corner of a triangle to the opposite side that has to be perpendicular, meaning that it has to have a right angle. And the area formula for a triangle works for every triangle because every triangle will be exactly half of the rectangle that has the same base and height. So the formula works every single time.